Welcome everyone to another Linux open source live stream. I finally benchmarked GCCs again. I've done this commercially 15 years ago for the German Linux magazine, which is also where I created this tiny little open benchmark, aka a little bit of spec-like thing, because spec, that previous big benchmark, was commercial, although they used GCC and Perl and stuff. If you're wondering, for this test runs, they are relatively short because I also at times want to benchmark vintage and retro, like SG Octane and stuff, for comparison. So yeah, a quick benchmark, actually, also because I needed that. Why? Because obviously we built one of the best Linux distributions here, supporting 25 or 6 architectures here. That is T2, just raw, mostly vanilla Linux. And obviously it's always good to know what is fast and what is slow, and what are the parameters. Also, if this is just a quick benchmark that took me 1 or 2 hours, like, yeah, this tiny little collection, 1 or 2 hours easily, because complexities and failing stuff. So what does it mean for us? So this is a runtime. This is GCC 10 because that was what I had on this older T2 installation, VM server, and GCC 12 with various options. If your favorite options are missing, leave them in the comments below, and probably I will sometime soon, because now we have not only a growing channel and our Linux distribution in such an amazing state that I can focus on some more fun things. I will probably try to benchmark as many GCC versions I can get working on a modern system, from GCC 5 or so to 12, just to see how much slower and faster build time and runtime GCC became. Some are missing because libmet somehow doesn't compile in some configurations, and the error was something like size of, and I can check this, it's probably somewhere like here, and that is whatever is. Yeah, so much to benchmark. I probably also another day need to use more benchmarks. Libmet, that is GCC, for example, pi or stuff, and yeah, cannot compute size of int77. It's like like the only constant is change and strange regressions. Like, yeah, I need to look into that craziness another day, but that doesn't matter so much. Also, because of a set standard C compatibility issue, I don't have results for GCC 10, because before I installed GCC 12 into the system, I didn't notice that set standard was broken there, so this is why this result's empty. If we take a look, so runtime is running the benchmark, and as you would expect, mostly, like, also GCC, that is just the sorting, right? The OG is of course the slowest. It is just alphanumerical sorting. Not ideal, of course. So obviously that is usually the slowest, not the biggest surprise there. Aside from that, 01, this is also GCC 10, 12. You need to be careful reading that, right? But not the biggest surprise there. The more you optimize 01, 02, 03 fast, the faster it usually gets, except outliners. Here, if you look at surprisingly, actually not GCC 10. So GCC 12 appears to have a regression here. And I had this previously, right? I benchmarked previously the great risk versus risk shout out there 2 years ago on my main channel, where we benchmarked 25 systems, SG Octane, Beagleboard, and whatnot, Pentium, and so on. I had at times that libmet produced strange results. Also, pro tip, this benchmark should have assembly optimizations disabled, because I want to benchmark GCC before you shout. But the assembly optimizations, which actually some other websites don't realize, and they just benchmark hand optimized assembly stuff. It's not the point of. It's the point of benchmarking MP3 encoding, but not benchmarking compilers. That's why it should be mostly only C. So yeah, libmet, that needs, for future benchmarking, I need to either make libmet sources more C standard conformant. But yeah, I mean, the thing is, the point is also, the point of benchmarking and independent benchmarking is also to really find what is broken, right? So obviously there is some libmet incompatibility or regression. But for the most part, if you look at something modern, here GCC, also you don't see that completely because my face is in the way. Let's make this like that. So yeah, the more we optimize, the faster it gets. And the biggest point, also, but not by much, right? I said this already or I wrote that in the Linux magazine, my last Linux magazine article, 2005, 6 or something, I said back in the day, the compiler cannot do magic, right? The compiler can, because so it's not rewriting your algorithms, right? If you write an inefficient algorithm, your C, C++, D, C hash, Go, Swift, Java, Rust compiler will not rewrite your algorithm, right? So some developer thinking still required. And also, I said previously, I wonder why we don't write code in more formal ways of math formulas, of algorithm, or like even pre-algorithm. I want this mathematically concepts like think 3D, coordinate and texture transforms and stuff, and have the actual compiler system think Wolfram, Alpha stuff, just brainstorming a little bit of like, why do we still write so imperative code that the compiler can't like apply all the algorithms we learned in hundreds of years. But anyway, so the compiler can obviously only optimize that code in what it's possible in the programming language in the algorithms written. And for me, the biggest point of this video, which is also the biggest point why, or this benchmark, why I did this today, is I wanted to see when we build our Linux distribution with position independent executables, which yes, I know some other distributions have done for a long time for more user space, address, layout randomization, but also SSP for stack smashing protector strong, and now new with GCC 12 here. This is a little bit clobbered, but what that stands behind the bar graph is initialize trival auto vars 0. It's like, and the question there for me was, if we build with improved hardening, reliability, security and stuff, how much performance do we lose? And the good answer is, let's just check. So they are all GCC 12 sorted by that. And to my surprise, here Pi was even faster for some strange benchmarking timing accuracy reasons. With stack smashing protector, it becomes a little bit slower again, so there is a tiny little overhead, and that is exactly what I wanted to benchmark today. And this is even, oh wait a second, these are two, so this is strong here. So that is stack smashing protector. I need to work on the sorting probably in some way here. And then with autovar, trival autovar init, initialize to 0, a little bit slower. So what does it mean for us? It means for us, I'm still a little bit, these are micro benchmarks, right? So if you build all of GCC and all of LLVM, which is also crazy to benchmark because building LVM epic thread wrapping through that takes 7 minutes or so, plus killing another 7 minutes or so with the latest GCC. Anyway, I probably need to add a variety of different benchmarks here. For us, this means we hopefully don't lose that much performance. However, for me, building so many sources, it becomes a little bit annoying how slow stuff becomes. So I really need to think what we really want to do. We could theoretically classify packages, say, okay, stack smashing protector and trival var, auto var initialization to 0 is not usually worth it for like GCC because that's not a attack surface for your server. We could theoretically mark stuff like server applications. A trival thing would be, we could, everything that has init script and run level daemons like Zambar, Apache, Nginx or Nginx and Secure Shell and stuff, or manually like, or use that as a base plus manual tagging, like tagging all security related software so that we don't build like, let's see, a window manager. The only thing is, where do we stop, right? If we want super top-notch, more secure Firefox or Chromium, we probably would want to have it there. So it's not only nowadays modern desktop workstation or mobile phone, not only your system services, but obviously your browser. Where do we stop there, right? And also, obviously, we don't want to look like the slowest Linux distributions. Obviously, we want to be the fastest, right? And that is the thing, right? Between running with booting your Linux kernel with mitigations equals off and like YOLO optimize fast, which also I did here, obviously, and which at times can be a tiny little bit faster if you see like lame, whopping seconds faster, or nearly, not the whopping, actually that is untrue, only 1 point live on this channel, actually no, that is nearly a second, or over a second, can be over a second faster in this MP3 encoding thing. Yeah, stuff is difficult. It's a tough decision, especially if we want to compete with the most optimized Linux distributions that Intel might push out there for their Intel-only optimized fame. But yeah, either performance, or security. The only thing, so it's a tough choice, leave in the comments below. Maybe we improve, maybe we switch it on and see when it annoys us too much. The only other trick I have actually, you know what, I forgot something, I forgot OS. Good that I noticed it now. Usually like OS. Did someone comment something? This stuff is of course open source. I will probably, now that T2 is in such an amazing shape, maybe I should spend a day significantly improving this open benchmark stuff. I'm not reusing other big benchmarks because, again, I want some small open source reproducible thing. For me, it's not the point to benchmark Firefox or Node.js. I want like reasonable sized benchmarks that can still yield results on embedded boards and vintage and retro stuff. So in the future, leave in the comments below what more we should benchmark. What do you want to see? I've chosen some useful stuff, useful to me stuff. Here I slightly wonder if we should even benchmark OG, because maybe we put that in a comment, because it might not be the most useful. OS certainly more useful than OG. But it was, of course, a good test set to make sure that all the stuff is working. The only better thing that I could imagine, which comes back to my microkernel, which obviously, yes, any day now, knocking on laminated wood. But the only other thing is jitting the stuff, right? If performance is so different, actually it would be cool if the user could choose it and accept using T2 and building your whole system with just the right settings that you want, that security, which is of course quite electron consuming and epic thread ripping, CPU cycle consuming. Would be if we would JIT it to my microkernel ideas there from 2 years ago. If like, yes, Java and there JIT exists, but thinking translator code morphing, which yes, was also not the fastest, but I'm thinking the modern C runtime does quite a bit on startup, all the relocations and stuff. And you don't need to JIT everything, and you can ahead of time JIT like Android system optimization stuff. Building this to bytecode, to relatively optimized bytecode, even with like scalable vector extension, because it is the other thing. I didn't even benchmark like all the x86 version 1, 2, 3, 4, 5 of AVX and SMD stuff. Recurring theme here, that usually you run not that optimized software anyway, due to the smallest common denominator there of your SMD implementation stuff. But yeah, the best thing I could still think of, yes, JIT has some overhead and stuff, but if we only JIT, like you don't need to JIT everything of set standard, right? You only can JIT hotspot and only JIT what is used, and then hotspot optimization, yes, decade-old Java technology, although Java was complex. Of course, it needs to be, I'm not saying it's easy, right? Just if we want this flexibility without recompiling your whole distribution, supporting the latest and greatest single instruction multiple data and security features, then it would be a cool thing that you could, like with just like that, a system daemon option of your global JIT stuff of, or even, not even global, but per package, that JITting OpenSSH with more security features and so on. Somehow, to me, all those pre-compiled static binaries, despite with T2 having one of the most flexible distributions, being able to rebuild everything, to rebuild world. Even I don't rebuild world because it's just too time consuming and electron consuming and so on. So yeah, Yes, JIT is difficult. For me, it's still, like after 20 years, JITting, flexible JITting, even C and Rust would be an amazing thing. Until now, that's what we have. We can only make reasonable choices. What I will probably benchmark soon, I have two things, and I will probably also try to make more sophisticated videos out of this, now that we have 10,000 subscribers on the Mormon channel, kind of sort of nearly every day. And like benchmarking the GCC versions, and then also like, obviously these are two things, benchmarking the GCC versions, how much performance did we really got the last 15 years, and benchmarking one version of GCC, like GCC 12, and benchmarking all those fine-grained x86, for example, x86-64 ISA versions, this new stuff of V1, V2, V3, V4 for this. Maybe not perfect, but at least somewhat. We could do that manually of SSE to AVX, AVX2, AVX 512 and stuff, or otherwise use this hardware capability x86 version either things there and see what this different ISA versions bring. But even then it's not easy, because even then we have all those ISA versions and then O2, O3, O-fast. But yeah, somehow it's, yeah, the possibilities are endless, the combinations are endless, and it's also somehow crazy that we don't have a better solution for that. The best solution I would have, which, yes, complex, and you have seen a transmitter in Java, that it's not easy and peak performance is not guaranteed, but it would be cool if we have something with Android, but anyway, flexible choice would be cool. The only other thing I will probably do with T2, and leave in the comments below, what should I benchmark and what would you have your operating system, aka T2, default choices being made. The only thing I will probably add after this live stream, so that's basically it for today. Also, we have also build time, but build time is not that interesting, except yeah, the more you optimize, those longer GCC takes, right? So O1 and then, or like OD debugging and then O1, and it's like, yeah, basically also then O3 and O-fast. It's like, yeah, also all the position independent code and stack smashing protector and stuff like that's not influencing the build time the most. But then O3 and O-fast is like obviously the next level there. Time consuming, of course, only relevant for you if you build sources, like if you're a software developer or you build your Linux distribution from source. And also theoretically we have size. Did I upload that? Maybe I uploaded that, but the size diagram is somehow messed up, whatever. It's probably not, whatever. The size increases significantly with O3 and O-fast. So the biggest takeaway for me is what I wanted to see, stack smashing protector, position independent code and variable initialization is not as costly as I feared. The new GCC can generate at times a little bit faster code, and I will probably add no O-fast. However, O-fast is dangerous, so I will probably, so not only, I will add two more options live on the next live stream in 5 minutes. So that's basically the summary. And for me, that probably means let's try. We have the smart optimization of optimizing everything for size, because most, like 90% of the code is never run. Like command parsing and other algorithms, right? Optional algorithms or rarely used algorithms and stuff. Or log generation and debug stuff and so on and so on. And we have the smart of optimizing everything for size except hot files. That is in T2 a per file thing, because we don't have a finite granularity there of launching GCC. I will add O-fast just because it's of course a little bit unsafe, but yeah. But I will personally not use it. It's just for you if you want to use it. We could even mark packages in our metadata of this package not O-fast because they're broken. Too heavy, like this is certainly the man page obviously says don't try this at home and so on. This is disregarding strict standard compliance. It's certainly more. You obviously don't want to do that at home, right? Enables all of 3 optimizations. It also enables optimizations that are not valid for all standard compliant programs. It turns on fastmask, store data races, and for specific stuff, and protect parents in terms of semantic interpositioning. And I think I do a test build and see what breakage I find. Hopefully, fingers crossed and stuff, hopefully none. I will probably add also a smart test. We have only smart, smartly, smarter, because obviously we need such variations for all those variations of build stuff. Also some break on some architectures, right? So smarter, our OS/03, I think miscompiles on Spark 64 because 03 on Spark 64 currently internal compiler errors. And I probably add smartest, aka everything size except hot passes with fast, and just see how that goes, because why not? So yeah, hope that is hopeful in some way. I always wish I would have even better results, but this is just the results we got there. Can't change that except better sorting. As usual, leave in the comments below what you want to benchmark, what your distribution should use by default, and don't forget to share, subscribe, and in 5 minutes the next live stream of implementing fast and smartest in T2. Hope you learned something and see you soon for our next fun and live stream to come.